Hey, Dave here with a video on laptop hard drive recovery. And so here we have a hard disk drive from a laptop. This is a 2.5-inch magnetic-based drive. And in fact, this was the old drive in this laptop before we upgraded to a solid-state drive in here. Now, this drive had an error. It was an NTOS kernel.exe error. And I show how to fix that in another video. For this video, we just want to recover the data from this drive. And so there's a couple ways to do that. First, we could connect this drive internally in a computer via SATA, or you can use an adapter to connect it directly to a PC or a laptop. And so this adapter has SATA on one end, and that's for connecting to the hard drive. And the other end is USB 3.0. You can use this USB 2.0 as well, but 3.0 is going to transfer data a lot faster. That's it. The power is transferred via the USB port from the laptop through here and through the SATA 15-pin power connection to the drive. So this will spin up, and it should spin up, and it should we should be able to get the data off of it. Now, this works fine. USB supplies enough power for a 2.5-inch drive, but if you have a 3.5-inch drive, something internal for a PC, and you want to get the data off of this, this adapter will probably not have enough power. So you need an external power source. And so, again, you could connect this to the inside of a computer, or if you have a tray and frame combination in the front of the system, you could use that. But I also have another adapter here. And so this is for getting data off of just about any drive. So here we have an SATA connection. And you would connect the SATA cable, and the other end would go to the hard drive. And the other end of this adapter is USB, so you connect it to USB. We also have old school stuff here. We've got 40-pin IDE for 3.5-inch drives, and IDE for 2.5-inch laptop drives. And you'll probably come into contact with older drives that are IDE that people want to get their data off of. So a tool like this is invaluable. But that's only the data side. If you have these bigger drives, for example, here's the SATA drive. If you have these bigger 3.5-inch drives for PCs, and here's an IDE drive, then you need that separate power. So a device like that comes with a power brick, and you just connect a regular computer power cable, an IEC power cable, to an AC outlet. And on the other end, we have a Molex connector. So the Molex connector can work great for older IDE drives, or any drives that use a 4-pin Molex connector. And if you have a 3.5-inch drive that has SATA, they make these that go to SATA directly, or you can use an adapter. This kit comes with an adapter. It's a little bit of an older kit. And we go from Molex to SATA. And there's a power switch on this. So external power for that hard drive connection if you're using the 3.5-inch drives. So that's a great tool to have. I can get data off of just about anything. But we're just doing a data recovery from this 2.5-inch magnetic-based laptop drive. So this should be enough. So I've got a laptop here, the laptop that I actually upgraded. And we're just running Windows 10 on here. And let's take a quick look. Here's Windows Explorer, File Explorer. And we've got a C drive for the operating system and an F drive for our data. So keep that in mind. And so with this, we can plug this guy in directly right while the computer's running. But in a lot of cases, I'll shut down the system and then plug it in. That's generally what I like to do. So we'll connect that SATA connector right to the drive. And the other end, USB, we'll connect that to a 3.0 port, one of the blue ports on the side here of the laptop. And I can feel the drive spinning up. I can feel it turning. Let's see if File Explorer finds the drive automatically. Here we go. And it says, local disk D, there's a problem with this drive. Scan the drive now and fix it. Yeah, there's a problem. The N2S kernel file failed, and probably other Windows files. But it saw it, and it saw D and E. So we've got D. And again, it's right when I plugged it in, it started spinning up. And you can feel it. It's vibrating right now. You can feel the power flowing through the cable. But anyways, we see that D drive. That is actually the C drive of this other hard drive, and that's where Windows was installed. And in fact, we've got multiple versions of Windows installed on this. You know, it was just a matter of time before this magnetic-based drive failed. And then we've got the E drive, which has data. And that's the kind of stuff that we most likely would be trying to capture and recover. And so it's looking like it works. Works pretty good. It's seeing the drive. The drive is working properly right through USB. So that's what we want. So let's say that we wanted to recover some of this data. We could just copy it. Just right-click on there, copy, and we could put it wherever we need to, but I'll just put it to the C drive for now. Let's see how fast it moves that data. I think there's about 1 gig of data in there. Okay. And done. Skip that logins folder. And according to my watch, it took about 10 seconds. 10 seconds on my watch to move 1 gig of data from this drive through USB to the laptop. So not too bad. And that's it. That's how you recover it. I mean, obviously, we wouldn't go to the C drive. We'd want to recover this to the proper location, probably a different partition, maybe a different drive, maybe some type of archival, who knows. But there it is. That's how we can recover that. Now, a couple things that you got to check. Now, it could be that you're not sure which volumes are for which drives. If that's the case, we can go to our disk management utility with the disk mgmt.msc. And the disk management utility will look for the different drives, the different disks, so to speak. Well, we had upgraded this laptop and we put a solid state drive in here. That is the drive that's running the operating system on its laptop. That's the main drive. It's the first drive that should be listed. And it is. It's called disk 0. So that's the solid state 250 gigabyte drive. With the C partition with the operating system, that's the boot, and an F partition for data. Then we have the second disk, disk 1, and that is what we plugged in here. And it does see it, and it sees the D drive, which is where Windows is installed on that drive, and the E drive for data that I was using previously on that drive. Now, in some cases, the drive might not be recognized in Windows. Even though you plug it in and it gets power, Windows might not recognize it because it has to be initialized in disk management. And you would do that by right-clicking on the disk and selecting initialize. And, this is initialized. It does see it and sees the partitions. But in some cases, it depends on what's on that drive. If there's other items on there where there's no type of known information or boot partition, then it might not initialize automatically in Windows. So you have to actually right-click it in the disk management and initialize it. Then it'll see that stuff. And then you could view it within Windows Explorer. Right? So that's it. I mean, the tools that we're using here, it's pretty straightforward. We're using a cable. It's an adapter. Pretty cheap. Should be in every PC technician's toolkit. And then we're just using a computer to copy the data to, like a computer with Windows. And we have to know how to use File Explorer and disk management. All right. So there you have it. We have copied everything over, and it's looking good. So at this point, I'm going to close out of here, close out of this, And you always want to safely remove these types of things from USB because this is running right now. Didn't start running till after I plugged it in. So plugging it in while the computer's on, not too big of a deal. Quite often I'll keep the computer off when I do that, but not a big deal for plugging it in. But unplugging it, no, because it's running right now. It's getting power from that USB connection. So we want to safely remove that connection. So we'll do that in the notification area here. And we'll right-click on that safely remove hardware and eject media and select that guy. This is an ASMT 1051. That's the adapter. Okay, we'll double check that. So there's nothing now to safely remove. Looks good. But the problem with this, as far as data goes, this has been safely removed. But I can feel this drive is still running. And in fact, any drive that you connect via an adapter like this will still get power via USB. So the drive is still turning. It hasn't parked. And if you care about the drive at all, you're going to want to make sure that it parks properly. So you don't want to just disconnect it and cut the power in that way. You're going to want to do a shutdown on the computer. And so I'll do that now. Do a shutdown, give that a moment. Come back here. Okay, it's shutting down now. I just heard it. And the hard drive spun down and it's not vibrating anymore. So now it's safe to actually disconnect this guy. Always pull straight out when you're doing that with this SATA connection. So that's it. Remember, to work with 2.5-inch drives, you can use a simple adapter like this that goes SATA to USB, and that can handle powering the drive and sending the data. But if you're working with a 3.5-inch drive for a PC, then you're going to need something with separate power for that 15-pin power connection, like that adapter that I showed with that separate power connection here. Something that plugs into a wall outlet, a separate power source, because you're going to need more power for that. And either SATA or Molex for other drives and older drives. Or again, you could plug this directly inside a computer. Just connect it to another SATA port or use a tray and frame type of thing in the front of a tower computer in a 5.25 bay. So lots of options there. And at this point, you know how to recover data from just about any drive. Now, in some cases, if the drive was really damaged and had seen a lot of use, there could be corruption of files. There could be files that are more difficult to recover. That's when it gets a little bit more tricky, and you'll have to use data recovery software at that point. And there's some free, and there's some that cost a lot of money. And there's a variety of ways around that. And there's other tips and tricks for doing data recovery as well that are free. But that's a whole nother course unto itself. Here I'm giving you the basics on how to recover data from a drive that had an issue. But you may have to use other software to actually go further in the recovery process. All right, so that is it for this video. Get yourself one of these adapters. It could be a lifesaver. People will thank you. It should be in every PC technician's kit, every computer technician's kit. And that's about it. I'm Dave, signing off, and I'll see you at the next video.